two detectors, opposite sides of a city. Each one measures a particle from the same entangled pair. And when you compare their results, the pattern breaks a rule every local predetermined answer has to obey. That broken rule won the 2022 Nobel Prize in Physics. And despite what you may have heard, it does not mean reality is fake. It also does not let anything outrun light. So what does it actually mean? First, the object on screen is a quantum setup for entangled photons, not a tiny planet with a path. In the 1930s, Einstein had a problem with quantum mechanics. He thought entangled particles should carry hidden instructions, the way a left glove and a right glove are already decided when the boxes are packed. Then, in 1964, John Bell asked the question nobody had turned into a lab test. Suppose Einstein is right. Suppose each particle carries a preset answer for every possible detector setting. Bell found that local preset answers have a hard ceiling, while quantum mechanics predicts more. Bell turned a philosophy argument into a scoreboard. Here is how the test works. Alice and Bob each have a detector with a dial they can set to different angles. A source in the middle fires pairs of entangled particles, one to each detector. For each pair, they pick random settings, measure, and record up or down. They repeat that thousands of times, then compare notes afterward. If the particles were carrying Einstein's hidden instructions, the correlation score would stay below Bell's limit. But when physicists run the experiment, the score crosses the line. The quantum prediction wins, and the margin is clear, repeatable, and impossible for a local instruction card story to match. That is what people usually mean by not locally real. Your chair is not an illusion, and the moon does not vanish when nobody looks. The broken idea is narrower, that each particle left the source already carrying a definite answer for every possible measurement, and that nothing about Alice's choice could matter for Bob's outcome outside the light speed rules of relativity. But here is the part people get wrong most often. Alice sees random results. Bob sees random results. The correlations only appear after they compare their records, and that comparison still has to travel through the ordinary world. There is no way to use entanglement to send a chosen message faster than light. The first real Bell test came in 1972, when John Clauser measured entangled photons and found the violation Bell predicted. In the early 1980s, Alain Aspect sharpened the test by switching detector settings after the photons were already in flight. Then, in 2015, 3 independent groups ran loophole-free Bell tests, and in 2022, Clauser, Aspect, and Anton Zeilinger shared the Nobel Prize in Physics for this work. So, what is nature telling us? The universe does not fit the story where particles carry local instruction sets. The correlations are real, measured again and again across large distances, with settings chosen to block the obvious escape routes. In some tests, ancient quasar light even helped choose the settings. And still, those correlations cannot carry a message. The universe is stranger than Einstein hoped, but it still follows rules, just not his.